Hello ninth graders, welcome back to my class. Okay, so today we are going to study about the negative indices. Yeah, this is the subtopics of the indices. In the previous meeting you have learned, right, about the law of indices, right? There are several laws of indices. You probably remember it, right? But right now, I will just focus on this negative indices. Why we need to focus with this? Sometimes students get confused with these negative indices, and why should we rewrite these negative indices as reciprocal or a fraction? And what is the aim or the benefit of studying negative indices? I mean, what we can apply negative indices in our daily life. All right, so let's find out. So here I have three words here: the index notation, negative sign, and reciprocal. All right, so index notation, here any numbers that express in index notation and it has the opposite sign or negative sign, we can rewrite this index notation or this number by reciprocal. So, what's this? Let's see. Okay. So, example here. So, if you have 10 to the minus 2 power, so it means this one is reciprocal of 2 square. Or we can rewrite as 10 to the minus 2 power equals 1 over 10 square. So this one is the index notation with negative sign, and then we can rewrite as the reciprocal 1 over 10 square. So you should rewrite as positive index. All right. So this is the example. All right. So the example one here we have, we need to rewrite or write 5 to the minus 1 as a fraction. A fraction with reciprocal is the same. So this one is reciprocal of 10 to the minus 2. So the forms of this reciprocal is fraction as we call it in normal numbers. So this one is fraction. So we can just express as fraction rather than reciprocal. So write 5 minus 1 as a fraction. So the solution here, you just using this equation, yeah. So you just put 5 to the 1 as positive in the denominator of fraction. So in the end, you got 1 over 5 because 5 to the first power is 5. All right, what next? Okay, example 2 here. Write 1 over 9 in index form. Now, this is the reverse, yeah. If before we need to find the reciprocal or the fraction, now we need to find the index form. Okay, so how to find it? You can write 1 over 9 as 9 to the minus 1 power. All right here. However, 9 is also equals 3 square. Remember, we already studied before about factor or the factors. Okay, the factors. The small factor, I forgot the name before, the opposite of the composite. If you remember, you can remind me, okay, in the chat. So 9 also equals 3 square. So 1 over 9 equals 1 over 3 square because we rewrite 9 as 3 square. So at the end, since we want to find the index form of 1 over 9 or 1 over 3 square, so it will be 3 to the minus 2. So both these answers are correct. So if you rewrite 9 to the first minus 1 power or 3 to the minus 2 power is also correct. All right. We just simplify as the smallest factor. Okay. And then what next? Here we have now how we can use in algebra of this negative indices. So you can use algebra to express meanings or rules in general terms. So here you know that in numbers like fraction with the algebra is different. Why? Because in algebra you need to define the variable in correct way. For example, here g to the minus n power equals 1 over 9 to the n, right? So here you need to put the definition of g is not equal to 0. Why? Because if you substitute g with 0, it will be undefined. That's why we need to define as correct one like this. All right, in algebra. All right. What next? Oh, it's long. All right. Now, how if we dealing with the coefficient? So in this operation only you consider the base, yeah. So for example, if we compare these two expressions, the first expression and the second expression, I will make it bigger because it's too small, I think. All right. So like this. The first expression, 2 times y to the minus 3 equals 2 times y to the minus 3. So this one, we change as reciprocal. So we change the negative sign or the negative indices with positive as usual, and then multiply by 2. And then you compare with this second expression. So 2y inside of parentheses, and then it just rise to minus 3 power. So in this case, we need to take 2y all and then to the positive 3 as reciprocal. So in the end, you will have 1 over 8y cubed. Remember, this one is power, the first rule, yeah. 2 to the 3 is 8, and y to the 3 it will be y cubed. Okay, so the difference is if this one 2 is just coefficient, but this for the second expression 2y is one expression. Okay, and then why we need to study negative indices? So this one for scientific notation. Why we need to scientific notation? Because like this, if you imagine that very small number of very small things, if we want to find the value or the measure, it's very small and sometimes it's very close to 0. It means if, let's say, if you want to divide 1 by 1 billion, so instead of write down of 1 over 1,0,0,0,0, so many 0, so you can just write down as for example here 10 cube, right? So we transform the many zeros with the indices like this, and then for small or micro or nano, it's better to write the scientific notation using the negative indices. For example, here you have 4.7 multiplied by 10 to the minus 3. It means what here? Means 4.7 multiplied by 1 over 1000 or 1.7 divided by 1000. So it will be 0.0047. Imagine that it will be big number. Let's say it's 20 or 100. So it will be 0.000000. So it will be not good. Yeah, it's wasting time. So it's better if you can transform into indices. All right. So that's all for today. I hope you understand with my explanation. If not, you can just simply ask me by private message, or we can discuss it in Zoom meeting. See you.